Now let's find the graph of this function. You have to remember that the denominator will give you the vertical asymptotes. And the numerator will be the x-intercepts. Let's try to find both. If you want to find the vertical asymptotes, you would have to use x minus 1 is equal to 0. And your vertical asymptote would be at x is equal to 1. And the domain would have to exclude that specific value, getting you from minus infinity to 1 and from 1 to infinity. The horizontal asymptote, as you might remember, you have to think about the leading terms. And the leading terms are the terms with the greatest exponent. The greatest exponent is on this term, and the greatest exponent is on this term. Both are degree 1. So you have a degree 1 versus degree 1. That means that you're going to be using the leading coefficient. The leading coefficient is the one next to that x raised to the power of 1. So the leading coefficient is 1 on both. That will allow us to find the horizontal asymptote at y equals 1. The horizontal is going to be here. And at this particular instance, the vertical asymptote is going to be 1 as well. 1 being x equals 1, and the other one y equals 1. Those are our asymptotes. Now we have to find the x and y intercepts. So this is what happens if x is 0. So you need to plug a 0 into your function, getting you 0 plus 3 and 0 minus 1. So this is going to be equal to 3 over minus 1. You get minus 3. The coordinate will be 0, comma minus 3, 0, comma minus 3. And the x-intercept is the answer to a question, how much is ax when y is 0? So if y is 0, you can start with the function written in this form, x plus 3 divided by x minus 1. That would turn out to be 0 is equal to x plus 3 divided by x minus 1. And let's multiply everything by x minus 1. So that would end up being 0 times x minus 1 equals x plus 3. That will become 0. 0 equals x plus 3. So x is equal to minus 3. So as I mentioned, the x-intercept is simply based on what you have in the numerator. So x plus 3 is equal to 0. And you get x is equal to minus 3. The x-intercept is minus 3, comma 0. So we already have two coordinates on one side of the equation. Sorry, on one side of the graph. Now we need to find a couple more on the other side of the vertical asymptote, on this side of the vertical asymptote. So we're going to do perhaps f of 2. And let's see what we get. 2 plus 3 divided by 2 minus 1. 5 divided by 1. The coordinate would be 2, comma 5. The 2, comma 5 is about there. And from here, you can pick any other value that you want. So let's say f of 3. 3 plus 3 divided by 3 minus 1. 6 divided by 2 is 3. So your coordinate ends up as 3, comma 3. So that's 2, 3, comma 3, about there. The more coordinates you use, the more accurate the graph is going to be. So now from each coordinate, you're going to approach the vertical asymptote and the horizontal asymptote and the connection between the two. Here, you're also going to be approaching the vertical, approaching the horizontal asymptote, and the connection between the two.